Everyone.
Yeah, good
Okay.
afternoon, sir.
Good afternoon, sir.
Um, the other day, we had some questions left. Um, one minute, huh? Okay. All right. The first set, I think we have to answer these questions. Um, quickly, write a script to fix setup timing. Okay. So, uh, what will this be? Just to refresh, let me understand, what will it have? So what should you fix first in setup? What are the priorities of fixes for setup violation? Setup timing fixes.
Sir, it's set up, if we see setup in the ISO stage, then we have to check like we can analyze how many failing endpoints are there.
First we need to do swapping, it is swapping.
Yeah, if that is in ECU phase, then we can do ECU that swapping.
Even without ECU stage also we can do the swapping after routing stage.
Yeah, before ECU stage, we can check if there is a proper flow plan health done or not, or proper whatever rules are there, like according to model placement or splitting, so that properly has done or not. That we have to check before going ECU.
Yes.
Good. I think, Pooja. So I mean, at least you have started off well. So the first counter question is, whether the setup violation is in placement or in the post-route ECO stages. Okay, that should be the question. So whether it is in placement or CTS or post-route, so that should be your counter question to the interviewer. And so let us, if it is in placement, then you will look at, floor plan, module placement, and look at, what you can improve in terms of that, and also look at, if it's in if floor plan module placement is good, then you can look at some uh, optimization script, right? PCNopt hyphen you know timing effort high, or look at further optimization what needs to be done. So, but assuming that this is more to do with post layout, I mean that is basically in the STA. So what should be the setup timing fixes approach? Again, over here, I have told if this is the script, so the steps before we come to a script, you should first talk about the priorities of your fixes. You should first fix the, um, you know, the clock tran, clock DRVs, and see if there are some common path skew which can be used to fix the setup violation. Okay, before you do anything on the data, you should make an attempt on the clock path. So clock DRV and useful skew approach. Then you should try basically closing on all the data tran. I have already told, right? Anything more than 200 micron or 300 micron, you try to buffer long paths, and so attack the DRVs before you look at actual timing paths, because anyway you'll have to fix them, because once you have fixed them, many of the violations may come down. Okay, uh, even because even if you fix setup, you'll have to anyway go and fix the tran, but clearing up the tran will reduce the number of setup violation. So assuming your clocks tran is good, your data tran is good, and you have already used the useful skew concept, then what are the next steps to fix the setup? Okay. So setup timing has two things. One is flop to flop. The other one is flop to clock gating. Okay. So your violations could be on clock gating, and it could be on the flop to flop approach. So let us say if it is in flop to flop, then you can look at uh, again, you have to take a real see, there's no one solution fits all problem. Okay. So let us say there is space in your design, and you are looking at some options here. Then you have to first segregate. So your script should when it's addressing the data path, first it should segregate the timing violations in the descending order. So when we are saying that any violation like between 500 picosecond to 100 picosecond, 1 nanosecond to 500, 500 to 300, 300 to 100, 100 to 50, and 50 to 0 picosecond. Now you have to segregate your violation report in this manner, because you should not go and try the same solution for everything. Okay, you have to first segregate what is the number of violation. Now, if you are seeing that there is a violation between, let's say, 500 picosecond to 100 picosecond, right? And you can, so this should be first your report segregation. The second part of your report segregation is take all the, you are reported up to all the way up to 0 picosecond, and you can collect all the cells whose delays are, let's say, more than 200 picosecond or 100 picosecond, or more than, let us say typically in a 7 nanometer, the cell delay is supposed to be like 20 picosecond. Okay. So 8 picosecond or 5 picosecond buffer, and if it's like a 2 input AND gate and all, it will be like that single digit. But if it is like 4 input or 3 input, it could be like that. Complex cells may come to 50 picosecond, something like that. So if any delay which is like more than 40 picosecond, you collect those things. And if you see that their drivers are small, you just do a upsize. So that means sort out, okay, uniquify. This is what your script should do. Uniquify, sort out all that stuff, sort all the cells whose delay, that delay column, if you search that delay column, if it is greater than 40 picosecond, you capture them and collect all those cells and sort them off, uniquify them, and whichever is more than 200 picosecond, you can actually upsize to, let's say if it is 1x, then you can upsize to 4x driver. If anything is like between 50 picosecond or 80 picosecond, then you try to just upsize it to just 2x. So you have to take some heuristics like that. You have to take some decisions, okay, that your script should do, that it should only do 2x. Here I can do 4x. Okay, and now if you are actually having delays which are like 30 picosecond, 40 picosecond, and so once you have actually addressed all this 0 to 1, right? Any drivers like 0 drive cell or 1x drive cell or 2x drive cell, which is actually giving you large delay, you should try to upsize them. Now, if they are drive cells like 3x, 4x, and still you have this violation, you should try to swap them. Then you look at VT swapping. Okay. Now, if this particular bunch of violation is in a location where it's highly congested, sizing is a problem, right? Then you can try swapping only and try to do some route or look at net fixing. Those are things you have to really smart script it. Are you understanding?
Yes, sir.
Okay. So size the cells, weak drivers, which have actually, large delay. And also look at one thing, I told you about addressing DRV, then using clock skew. The third priority is removing the crosstalk. You have to kill the crosstalk. Because if your delays are because of crosstalk, you have to actually look at, why that crosstalk is there, either move the wire or it could be because of weak driver victim. So you upsize or you move the aggressor away. So you have to take an attack on the crosstalk. Then address clock DRV, address data DRV, use the useful skew to address the timing violation. Number 4, number 5, what you have to do is you have to kill the crosstalk. Okay, number 6. So this should be your priority. This is how your script should work. Number 6, it should look at upsizing all the weak drivers. Okay. Number 7, buffer all the long nets. Okay. Number 8, then what you will do is you will look at swapping, or if it's congested, then swapping will take a priority on a lot of your upsizes, because you just go and upsize, then there's a problem in that area, then you could cause DRC issue. So then you will look at upsizing, because upsize doesn't cost you anything on the route. Okay, it will improve your timing. It will give you betterment on the timing. But the counter to it is, your leakage may go up, but that is okay. Okay, because anyway, your sizing is going to increase your power consumption. But principally, whatever fixes you do, you will more or less concentrate not to create DRCs. So this should be your perspective, and that's why you are touching a clock, so that you will be able to get a common point where you can address more than one violation with a one single fix. This is what you have to do. You have to attack the start points before you look at addressing, upsizing the cells at the towards closer to the endpoints. So once you size up, you'll have to sort in your script what are the common number of start points, what are the common number of endpoints. If let's say there are in your violation there are 10,000 endpoints, but common start points are only 50. Then if you are able to look at those 50 violations, those 50 start points, and those 50, if they have any common clock gator or any common clock cell which you can early clock by 100 picosecond, then almost 10,000 violations are getting addressed. So you have to really before use your intelligence here, not just look at swapping, sizing. That's not the way. You have to really size up your design and figure out, why so many violations are coming. Similarly, if there are 10,000 start points or 100 start points coming to a single endpoint, you push that particular clock to that flop so that you're actually killing multiple violations with a single fix. Here, if you will think, okay, one violation, I'll just upsize, but you will have only inverse of 1 or inverse of 5. There could be hundreds of violation which is popping. You just to fix one violation, you may have to do 100 sizing. That is not a smart way to address your timing fixes. Is it clear?
Yes, sir.
Sir,
Okay. What all information will be in def? Did any of you do some study on this? What will be there?
Sir, if we depth
so
out
it
into
will
your
consist of it's like a placement DB. If you take them to a floor plan DB, it will consist of the port placement and macro placement.
Now let us say it's a sign of DB.
Sign of DB.
What will be there in the def?
Then if we take sign of DB, then we can go for the ECO stage. We can take that from from that SPEF. So that total metal information and pin information, port information, shell information, everything will be there. So def is the format of changing some other tools or something. We can use.
So
for
what is the
that.
difference between def and GDS? What is present in def which is not there in GDS?
PG information.
PG information will not be there in def.
In def, it will means like power information. It won't be right.
Power grid information will not be there.
Yes,
Will it not be there?
It will. It will.
Huh? Haven't you seen a floor plan def with all the power
Yeah,
grids?
yeah. It will.
So what's the difference? What's the difference between def, lef, and GDS? This I will not answer. I want you to do some homework.
Routing information will not be in left.
Routing information will not be in left. Meaning?
That in depth it will be that the area, tracks, nets, those information will be these tracks, nets information, this macro placement information of this placement information of this macro standard cells, IO pins, those will be in this def and also in left. But that routing track, that overall entire design routing information will not be in left.
The entire design routing will not be there in left.
No, the left is abstract view of cells. It only gives the idea about PR boundary and pin position and metal
If
area
you were to
information of the
write a
shell.
left out of your router design, what will it have?
So it will take all the metal information and pin information, shell information, abstract view of shell information.
A top level view.
Top level view like.
So what will the nets be? What will the nets have in the left? So your nets could be converted to blockage. You can look at it, right? So this is all like coverage. And in the def, yes, details will be there. Net length. Okay. So you'll have to be really clear about the difference between the def, left, and GDS. Okay. If def has everything, why are we using GDS? Just one simple question. Will def be a bigger file or left be a bigger file?
Def will be bigger.
F will be the bigger file.
Def will be the bigger file. Will def be a bigger file or GDS to be a bigger file?
GDS.
GDS.
GDS will be the bigger file.
Okay. So first of all, def will not have any information about your base layers. So write a table. Def, left, GDS, fill. Send me the detail. Okay. Next question, if macro width and height is 100 micron, what is the coordinates of macro?
0, 0,
Yes.
0, 100, 100, 100, 100, 0.
Okay. Good. So what is the metal stack, this one? What does it tell you? So I'll tell
Metal
you
13.
this. Yeah, so this is the 13 metal layer. So that is one information that you get. Okay. The second information you will get is the this is a 1x width M1. M1 is 1x, M2 is again 1x. Then A1Y, A. Okay, so this the next 5 layer, the next layer is A1. Whatever is the definition of A1, right? A1 by A. So that will be the width of that pitch of that metal layer, and 5Y means the next 5 layers. So first, this is M1. This 1x is M2. M2 will also be 1x pitch. The next M3 will be A1. Then M4 will be YA. And M5 to M8 will be, this is what is 5Y2. Okay, 5Y2 pitch. And then, the next metal will be of YY thickness. Okay, 2Z like this. Then comes the final RDL layer, which is of, this type. If it is AL, then it is aluminum. Here it is like, what is UT? I don't, I think, some metal. Now, if you look at this M1P57, what does this mean?
Metal layer 1 with pitch 57.
So metal 1 is 0.57. That's the pitch. Okay. And M2 P40 means 0.40.
0.40.
Okay. M3 is 0.44. That's the pitch. That's the information over here. And what is this H240? This is like H300. It's a 6-track library at 240. Okay. So this again is like and if it is H300, it will be like 7.5 track. So whatever is if the track pitch is like 60 0.6 micron, like that, it's like multiplier 6 track like this. So that's the expansion. You can look at more details. Anyway, this information description, you will get it in the TSMC stuff. Commands to get one port to one register. So what does this mean is the commands to get, whichever register is connected to that port. What will be the command?
Change selection.
chain selection is the GUI option, no?
Yes.
You just want to get the port connected to the register.
PB get cells.
Get underscore ports.
Get ports. Okay, what?
Hyphen register name something.
Mhm. So if it's a particular register, for example, then you can say get port square bracket, okay, minus get ports minus of objects, open the square bracket, okay, um uh get get nets minus of, you can get the register, or you can do a all connected of that register will give you all the nets. And from that, all the nets, you can actually look at, which net is connected to a pin, and you can get the attribute. If that attribute is a port, then you can report it. Okay. You have actually multiple ways. Two of them I have already stated to you. What is there in timing report?
In report for setup, hold,
Start
slack,
point, end point, and slack,
clock frequency,
Ran,
entire clock part data.
skew, arrival time, required time, and based on the delay path type, you can take slack
So,
violation.
first you'll have to answer, right? Assuming this is report timing. Okay. So report constraints, all violators also will have different timing information. Now, first thing you'll have to actually kill that question by saying, okay, so I'm going to answer this question, assuming you are asking for report underscore timing. Now, if it's a report underscore timing, what all information will be there? You set start point, end point, slack. You can get, what else you were saying?
Means slack, start point, end point, which delay type.
There are all the cell nets in that data
And
path. Okay,
then
whether it is
they-
violated, you can even get the information of crosstalk like delta
Yeah.
variance.
Each
You
cell
can
of
get the
delay.
information if you give the option to specify, the derating factor that can also be present in your timing report, right? You
Yes,
can
sir.
even get the information of the uncertainty value used. You can get the information of your derating. You can get the information of, the library types, cell library types used, right? You can get all the information that is required in the timing report. You can specify these things, okay? And you can also mention, if you put my hyphen type, path type, full clock expanded, then you will get the clock arrival time and also capture clock. Okay, so that you can understand, how the whole clock tree is actually, being scaled up, etc. So you can get all the insertion delay information. All right, question number 7. Which one you use first method to fix setup, VT swap or size? What's the question?
So first we'll go to VT swap.
Huh.
Then after we'll go to size cell. So based upon that delay also, if it is 3x, 4x, then we can go to, if it is giving more delay, then we can come back to
Huh?
some sizing. Like if setup sizing is if drive strength is more, sorry, drive strength is low, we can go to size. And VT swap also after that.
So you answer this question this way. See, VT swap doesn't impact routing. Okay, side cell can impact local routing and congestion. Okay. Now, how I'll make a decision whether I'll use first VT swap or size. Okay. This depends on, whether there is local area, there is congestion, or, there is some free space. Okay. Now, if VT swap would solve my problem, right? I would use that. But if there's a weak driver like 0, so this is how you need to address. So if that would solve my problem, then this is what it is. But if the cell is a weak driver, if the violation is more than 200, VD swap may not help me much. So then I'll have to go with sizing.
Yes.
So, but principally, if, as you get closer, you will try to do the swapping so that there's minimal disturbance to the routing. See, by the set of questions that he's asking, it is very clear this guy is more like a physical verification engineer who is actually asking you the questions. Okay. So his concern is how you will implement the ECO, what you would do. So you would be able to size up your interviewer also. Okay. The next question, number 8. How will you run ECOs after ECO generating?
So once we
What's
got the ECO file, we need to go to our router DB. Then we can remove that filler cells. Then we can store the ECO file. Once done that ECO routing, again once we will fill the cells and we can give to the file to upper this top level to generate the again timing reports.
Sorry?
So once we get the ECO generated file, we can go to our route DB. We will remove all the filler cells first of all. Then we can source the ECO file.
Okay, so first thing is there are two kinds of ECOs. Functional ECO, then non-functional ECO, which are your timing ECOs, or it could be IR drop ECO, etc. Okay. So first you have to ask the question whether are we talking about a functional ECO or non-functional ECO. Functional ECO, you can get it in two types: ECO by file or ECO by netlist. Okay. So if it's a ECO by file, that means this cell, disconnect this cell from here, connect this cell over here, like that you will get. Okay, and you'll have to implement output that netlist and check the formality, with this. So, but prefer to take ECO by netlist so that you are able to read both the ECO netlist and your principal netlist. You can actually do a diff and then consume and place those cells appropriately. This is how you will address the functional ECO. Okay, you prefer to take it functional ECO by, ECO by netlist. Okay, I prefer that way, but you can do ECO by file also. So now, and then you will check you will implement it. You will do an incremental route, and then you will place that wherever the cells have to be placed close to that cell to which it is connected, disconnected, and then implement that. Hand place those cells. Okay.
And one more, sir.
Go ahead.
And one more, sir, if netlist is not freeze, then we can go to the ECO netlist. But if netlist, if you want to go with the ECO netlist, netlist shouldn't be freeze, right?
Yeah, because after routing, there is a functional ECO which is coming. Okay. If the ECO is too big, which cannot be implemented, then you have to restart your entire PNR. Okay. So assuming this ECO is a small file, you will implement that functional ECO. Okay. So there's a functional bug, right?
Yeah.
It's getting fixed. So you will do. So you'll have to answer. When you answer questions like this, then he understands that you are intelligence. You're not just going with one group that you are only getting time ECO. Okay. Functional ECO, when you are getting, you will implement, you will freeze the database before you implement the functional stuff. And then you will verify, you will dump the netlist. And then you will read that, the functional ECO into your design, and then you will take the diff and then implement that. And dump the netlist, final netlist, and do a, basically a formal verification, LEC check between the final netlist which has come to whatever ECO implemented netlist which is there in your database. Both should be the same. Now you will do the hand placement or place the cells close by. Even in the ECO, place this cell over here. It should be like implemented such that the cell does not have any free movement wherever it wants, it should not be able to place. Should be the ECO should have to place the cell appropriately where it is connected. Now when we are doing timing issues, okay, timing issues can come in, you know, various ways. Okay, let's say they have added actually big cells. Then you will look at creating space in that local area, whether there is space. Then you will source that and you will try to do that placement, legalize it. Then you will do incremental route. Okay, so that there is short. I mean, then you will clean and then you will take it to the, you know, final cleanup. That's how you are going to run the timing issues or your stuff. So it has to be manually done and ensure that, you know, there is a, before you do the ECO, you will check that, you know, the timing has improved. You are sourced that in PT session. Make sure in the DMSA session, the timing is all improved. So question number 9, will you run ECOs from route or from design? So I did not understand this entire thing. So it could be like, you know, functional ECO, will you take the routed database, okay, to do your ECOs, or you will start from the start. So now it depends on the size of ECO. If the number of cells, functional ECOs which are actually getting added is like 100 or some small amount, 1000 cells, then you will try to do it in the route stuff only. But if the ECOs is so big that it is actually they are not able to see, sometimes it's very difficult to create a ECO database for the bug guys. They may give you a fresh netlist also. Then in which case fresh netlist, in which case you have to start your entire PNR. Okay. So depends on, you know, your situation. If they are able to give a small ECO which can be implemented by file, you know, small routing without impacting my timing or DRC at that stage, then I will start from the scratch, from the routes database and move forward, because I would have already done a lot of optimization. Okay, when you are actually, you have to restart. You have to make sure whatever timing fixes that you have incorporated, all that you should have saved in the files. Okay, and while you are doing a restart of your PNR, when you are reading the entire ECO, because you are not able to close it in the just in the routed stage, then you'll have to source those particular ECOs. Let's say you have done clock ECOs at the clock stage, then source that clock ECO at that point. If you have done some route ECOs, source those route ECOs, so that in one stretch, a lot of your ECOs are also implemented. You don't have to waste your time. Okay. So that way you will look at, you know, implementing your design. Okay. The next question, number 10, is it necessary to route again if you are doing ECOs only VT swap?
So not necessary.
Sorry?
And if not necessary. If we are doing only VT swapping,
If you are doing
then
VT swapping, then no need to
route
doing
again.
reroute.
Correct. So easier route or reroute in general, the VT swap, assuming the footprint is exactly the same, should not have changed anything on the route. But sometimes, you know, the cell library could have a flaw, and if it has actually swapped something, then you can check. So the best way to do is, ideally there should not be any change, but you can do a verified DRC. If the thing is exactly the same as before, no shorts, no open, or the same numbers, then you don't have to read out. But if there are some changes, you know, because of some library issues between the VT type and this one, then you may have to do some incremental touch-ups to your route. Okay. So don't blindly assume you have VT swapped and there won't be any change. No. You should verify using verify DRC, verify LVS so that the VD swap cell is not created any problem for you. Okay. So the answer is ideally no, but we will verify through verify DRC and stuff like that so that no route disturbance has occurred. That should be your answer. What's the next question? What is design rule check? What is DRC? What
Double
does
width,
that do?
double space. To avoid the EM and crosstalk.
So DRC is what is the purpose of DRC?
So these rules we can apply at the CTS stage before the CTS start. So it will apply when
This
we
is not NDR, Baba. This is design rule check.
okay.
This is DRC. What is DRC?
So min width,
If
min
you-
width, min
So
space.
basically all the manufacturable rules, right?
Yeah,
Whether
yeah.
it is spacing requirement, whether
Minimum
it
width,
is
minimum space.
yeah, so that all that can be implemented properly. Okay, so that what the manufacturer, the fab gives you manufacturability rules to specify that this is how things have to be done. Which is what against those rules, rule deck is what you are checking whether your design has implemented exactly as per the better fabrication requirements. Like it could also be like redundant vias may be requirement, min width, if there is different rules, all that has to be taken care, including like double patterning, etc., etc. So this need to be done. Okay. What's the next question? Did you work on EMI and IR? Okay, you know how to do. How will you fix EMIR?
IR we can fix with
spacing.
if dynamic IR we can go with decap cells.
First, let's talk about EM fix. How will you fix EM?
So we
There
can
was
use double
somebody
width
else
of
also
metal.
giving me answer. Huh?
Double width of metal.
Increasing the width of the metal. Okay,
Yes.
that could be one fix. What else?
Spacing also.
Huh?
Spacing between the metal layers, power.
Spacing is different. Spacing is different.
Spacing. What is EM violation?
The atoms are
Displacing because of
When high
High
current
current.
passes through, then
if
the
a high current
atoms
density is
get
there,
moved
atoms
from
will
its
be
position.
displacement from one place to another place. It causes to open or shorts.
So basically, because and this is not like initially it will happen. It can happen over a period of time, right? Due to constant bombarding of your electrons and cells, what can happen is hot electron effect, the surface could actually peel off. So there could be rupture in your net. Because the density of current flowing is more than what that net can handle, that strengthen, for let's say for 10,000 hours, but constant bombarding can actually create this issue. So that's why it can rupture. Once it tears away, the net tears away, then either if the net tears away and touches some other net, it can cause you short, or it tears away and breaks the net, then it is a open, right? So that's the electromigration issue. So because there is constant high density current flowing, so how can you either reduce the high density, or the solution should be in that question only, high constant density, current density, constant bombarding. That means either you have to strengthen the net or you have to reduce the current flowing. Okay. So these are only two possible ways which we can help solve the problem. Now, if you have to strengthen the net, how will you strengthen? You can
we can
increase
use
the
the
double width. You can move to the higher metal layers.
higher metal layers shielding.
Right? No, shielding, how will it help? Shielding won't help. There's no crosstalk. This is about the current carrying of that net. Shielding, how will it reduce the current carrying?
Like whenever we will shield in the interconnects with a protective layer, it will reduce the impact of electromigration, right?
Huh?
When we shielding metal interconnect, it will be there, right? So at that time, protective layer can reduce the impact of electromigration.
No. I told you
Adding
electromigration is a current density problem. Constant. How by shielding, the nets which are close by, how is that actually that they have no role to play in the electrons flowing through that net.
Then that
Not
is
crossed
that
up.
way. Yeah,
So we can add a guard rings. No?
Huh?
Guard rings.
Guard ring also no. How will guard ring help? Problem is very simple. You have a pipe. Okay, I'll give you a simple example. So assume you are a tanker. The output of a tanker is a big pipe, right? Now there is a high pressure water. If you open that, almost like 4 inches of pi r square of that volume of water is coming. Now you add a small pipe to the output. Will it be able to carry water, or the water will rupture? It will come out. So you'll have to add a bigger pipe to be able to capture and make sure there is nothing damaged and so on and so forth. That's the force. So either you will have to double the width,
or we can reduce the speed of water.
Yeah, something like that, right? So how will you do this in this case? Correct. So one is, why is there a high density of current? Let's say a clock net. You have like 100 fan-ins. Or why do we do fan-out fixing? Okay, because you have actually like more than 60, 70, 64 fan-out or 100, 200 fan-out. Each fan-out should get some minimal current for it to be able to satisfy, understand the logic level. Not that the voltage alone. There is you have to know your electronics properly. And so one of the ways is, you are actually being able to reduce the fan-out, split the net. Okay, you split the net means, what will happen? The current going through one particular, the trunk of the net will reduce, because it's only feeding us at only smaller portion of the fan out rather than actually bigger one. Okay, so the fix is reduce the fan out, split the net, increase the width of the wire, or reduce the size of the driver. You have put a big driver which is actually driving huge current. That is why you are actually not using any 24x drivers in your or 32x. Why do they put a stop on using big drivers? Why they should use? Why they should prevent it? Because those drivers will drive huge amount of current, which is going to cause you an EM violation. And that's why they say don't touch those cells. You are not supposed to use them until you have used the real big proper wire only for very specific purpose, where you are actually doing, RDL metal, where you are doing slotting. Then only you are supposed to use those drivers to drive that kind of capacitance. Otherwise, you are not supposed to touch them, because they will cause you EM violation. So the fix is downsize the driver, increase the width of the metal, or reduce the fan out, split the net. These are all solutions to it. Okay. Don't talk shielding, etc. They have nothing to do with it. Okay. This is not a crosstalk. There's don't get confused between electromagnetic induction and electromigration. So this is another common confusion that people have. Electromagnetic induction, EMI or EMC, electromagnetic compatibility, is about the cross noises which are coming from your side effects of the nets or cells or parts which are sitting close by. Because of your inductance effect, those particular nets or cell, they will cause additional current to flow into your net. They are causing electromagnetic induction. That is different from electromigration. So please don't be confused with electromagnetic induction, EMI, or electromagnetic compatibility to electromigration. Electromigration is purely a hot electron effect. You understand the difference? In a EMI, then you will actually move the nets when you are doing board design. When I have board routing, you have to actually take care, bring those things close by. You have to do a shield. That is like crosstalk effects. Clear?
So,
How will you fix IR drop? And now how will you fix power EM? You have power EM issues. Power EM, what you have to do is you may have to add more straps if it's a power EM, right? Electromagnetic, because there are, it's not able to drive that current, so, or move away the, cells over there which are actually consuming a lot of current in that area. You have to move those cells away if it's a power EM case, okay, because there is density of current consumption in that region. You'll have to either add more straps or you'll have to. So you understand how you are going to fix this. The solution I gave for signal EM, increase the width, reduce the driver stuff. Now power EM is a different problem, right? It's like current density in that area. Either you have to move high driver cells or clock cells away, or you have to add more straps in that area. That's the way you are going to fix the power EM issue. Okay. So you have to distinguish between signal EM, power EM. Don't give reasons like I'm going to increase the width. I'm going to actually, downsize for a power EM. No, you have to move the cells. You have to actually, because you have to either increase the current carrying capability in that particular area mesh, or you have to reduce the power current consumption in that area by moving some of the cells, pixels or region, displays, so that you can fix the EM violation. You can hand move the some of those. You understood? Now wire drop, how will you fix?
Double space of power and ground rails. Use low resistance
Double
metals.
space of power and ground. How will double space help IR drop? What is
IR drop
IR?
is
I
right.
into R
Increase
is
the-
what?
Width of the power and ground rails.
A width of the power nets. Okay. By increasing the width, how is IR drop coming down?
So when we go by increasing the width of the power and ground rails, then that resistance of the metal interconnects can be
Correct. So
reduced.
resistance comes down, so your IR drop will come down.
Voltage drop will be come down.
Yeah. Okay.
And decapacitors, decoupling capacitors we can use. Decoupling capacitors.
Decoupling capacitors, how that will actually bring down your IR drop?
So when we capacitors placed near the power and ground pins, it will reduce the voltage drop. Like it will capacitors will be charged and discharged, right? When the power is getting not sufficient, at that time capacitor will discharge and give the certain power to
So
the
it will
power
still
rail.
be able to provide you that supply. See, only for the dynamic IR, you can use decoupling capacitance will help, not for static IR.
For dynamic IR only, it will
Yeah.
maintain stable
For
voltage.
dynamic IR, your decoupling capacitance decaps will improve your dynamic IR, because even though there is a drop in that net, because it would have charged, the charge will be able to potentially supplement the voltage drop, because it will have charge to that voltage. Okay. So yeah, decoupling. What
No,
else?
we can use higher metal layers.
Yeah, that's basically reducing the resistance,
Yes.
right? See, how you will bring down the IR, either you have to reduce the current or you have to reduce the resistance, right?
Yes, sir.
Or the third one is you will add decoupling, okay, so that the voltage is charged, okay, for a dynamic case.
Yes,
So
sir.
what are the solutions to reduce the current?
Solutions to the current, we can use power gators.
Power gate you cannot use, man.
So when we use power gate, the unnecessary part of things we can stop the
That's
power.
only a switch off. If you have to do, that's not But even when that function has to be working, current will be flowing. Power gate is not a solution. Hmm? The current consumption has to come down in that area. You'll have to move some of the cells again, just like your EM, right? Move some of the cells. Okay.
Yes, sir.
You can add extra bump so that the shortest path to your current, right? That particular piece is brought down. So EM also you can improve. Okay. Add bumps in that area to improve your IR drop. Okay. You can move some of the dense, high consumption path, improve the net route. Okay. And you can in fact move some of the clock cells, which may be consuming more current. Okay. Away from that region. Yeah, these are all solutions to it. Okay. Did you work on low power design? Okay, these are all like answers what you have to say. Yeah, whether you have done, the answer will definitely not be no. Low power, again, you can again say, yeah, at the worst case, you have used multi-VT, right? Yeah, you can state in case you have used shut off, you have used power gating, or you have used actually multi-voltage, where you are required to use UPF, then yeah, you can state that. Okay. Otherwise, general basic techniques anyway, clock gating, multi-VT are all part of the low power stuff. But once they are talking about power shut off, power gating, or they're talking about multi-voltage stuff, then that's the next set of things. Okay. Then you can essentially say yes, if it is multi-voltage, you definitely need a level shifter. Okay, whether you need level shifter both from high voltage to low voltage, low voltage. So by default, you can add high voltage to low voltage, low voltage to high voltage. But high voltage to low voltage in some cases are not required if the voltage levels are very, very minor and can actually take care of the voltage noise. Okay.
Sir, also retention cells.
Yeah, so now retention comes in. See, multi-voltage means there are two different voltages which needs to talk. There, when two different voltages are there, level shifters will be there. Okay. When two different voltages are there, right? Other than level shifter, what other cells will be required? You can use a clamp cell. Okay. So that the voltage which is coming is getting clamped to your lower. So on the lesser voltage domain, you can have a clamp cell. On the higher voltage domain, you can have a level shifter. Okay. So clamp cell, high voltage, level shifter. So these are cells used in the multi voltage where the voltages are different. When there is a shut off, then you will need whether you want to use a retention or you want to use of course, the first thing is you will have to use a isolation. Okay. Isolation cells will be used, then you will have to use so whether you want to use a hand isolation or R isolation, will depend on your design. I can literally tell you how you choose that. And then you need to actually, whether you want to retain, you do a retention, that means you will have to remember the previous value of that, or instead of or and, that is another thing. Then in the retention case, you'll have to use a power gator, right? So you need power gating cells. Okay, or it should be a shut off from the bump itself should be disconnected if that is some cases. And multi voltage is not just like this. You also have dynamic DVFS also, dynamic voltage versus frequency scaling, where you can have a voltage regulator, on chip voltage regulator, okay, which can dynamically change. How you manage that is a different one, but these two techniques at least you can remember. In a shut off, you'll have power getting cells, you'll have isolation cells, and you can have retention if that is a requirement. Okay. Of course, always on cells will be there. Okay, always on cells, breaker cells. These things are all required. Any questions so far? Okay. What is coordination rectilinear? What are the coordinates of rectilinear block? What is the coordinate of rectilinear block means? So where the shape is different, you will actually put every point. It will start from the start point and coordinate will move as per the direction. So 0, 0, 0 to 100, and then it could be like uh, 20 to 100 or something like that, where it is moving on the Y, again on the right. You'll have to define each coordinate, and by the time it comes again back to 0, 0. So that's how you will specify. You understood, right? Let me take, say this is your 0, 0. And so like this, uh, here it may be a little difficult. Let's say if this is your rectilinear block, right? Something like this. Okay. Now you start with 0, 0. Then you will go to this, you will move in this direction and come back and rejoin over here. So 0, 0. Okay, this is 100. So what is this? X coordinate 100 and 0, and then move 100, 20, then again, 150, 20, and 150, 40, like this. Again, you'll come back to um, what is that? 50, 40, and then come back over here. It is 50, 20, and over here 0, 20, and then 0, 0. Like this, you will go and come back to your coordinate. That's how you'll specify the coordinate for a rectilinear block. How will you fix timing if there is variation in every stage, like place, CTS, and route? Like in placement, there's no violation, but in CTS, there is violation. But again, there is no violation post CTS. But in route, there is no violation, but in reroute, there is violation. Right? How will you fix this timing? So at the end, what is it? See, what is happening between route and reroute? Okay. So if reroute is after taking care of the DFM, that is you are adding redundant via and all that, then you'll have to address. So if there is a violation, let's say 50, 100 picosecond over here, and in placement there is no violation, you'll have to add that additional in the 100 picosecond additional margin by including that in the uncertainty, so that finally you are able to convert. So you can use a technique where you are actually over optimizing in placement. Okay. and then continue with that, and so that by the end of your reroute, all your violation are not visible. It's getting covered over here. Okay, so that is why you add additional uncertainty, either in terms of your set clock uncertainty. That's one technique. Second, you can use cell derating. You can use route derating. All these to capture the variations because of your route. Similarly, variation is not only in ICC, it could not only in a routed database. It could be post route, in your timing, the way it sees the things would be different, so that all the crosstalk, etc., would be done. You will factor them and bring them by adding uncertainties either to your frequency or to your deratings of your cells and nets. So that's the way you will address. Is it clear? Have you understood what I said? Yes or no?
Yes, sir. Yes, sir.
What is check timing?
So unconstrained endpoint, unclock point, IO delay missing, all this we'll get if we do check timing. Even unconstrained paths also we will get to know.
So check timing, unconstrained endpoint, then
Unclocked points,
unclocked registers, then
IO delay, if there is any IO delay missing.
missing IO delays, missing IO constraints, then
Unconstrained paths,
what's the difference between unconstrained endpoint and unconstrained paths? So unconstrained IO, unclocked registers, unconstrained endpoints. What is the difference between unclocked register and unconstrained endpoint?
Unconstrained endpoints means the clock will be clock will connect to that endpoint, but that is not in our constraint list. But that should means that is the false path line.
How will it be a false path? Why do you think? Okay, so you are saying the register gets the clock, but it is still not getting timed.
Yes.
So one of the reason why it's not getting timed by what you are saying is because there is a definition of a false path, and that's the reason it's not timing them. Is that what
Yes.
you are trying to answer?
Yes. Yes.
Correct. That is one of the reason. So unclocked means the register doesn't get a clock. So because it doesn't get a clock anyway, it will be unconstrained. The SI won't be constrained, and this again, depends on which timing mode. You'll have to run it, check timing, you'll have to run it for all the timing modes. Because this register may be timed in test mode, but in func mode, it is not timed. You understand? Don't go, this is a very mode dependent report. So you should not go by one flat report by that. You have to check in every mode, check timing. You understand?
Yes, sir.
More? Anything more? Are you ready? SDC commands. So see, this is like how will you specify create clock?
Create clock hyphen name.
First of all, tell
hyphen
me all the list of SDC commands generally. I mean, you may
Create
not know
clock.
sophisticated.
Create clock. Set input delay. Set output delay. Set the rate.
Set max transition.
Set
Okay, max transition. Okay.
Set clock uncertainty.
Set clock uncertainty.
Set disable timing.
Set disable timing. Okay.
set multi-cycle path.
Set multi-cycle path.
Set
Okay.
false path.
Okay. First, let's take one category at a time. Let's say for clocks, what all kind of SDC commands are there?
Sorry, sir.
For clock, you have actually create clock, create generated clock, set clock sense. You may not know set clock sense. We will talk about that. Not to worry, but at least you should say create clock, create generated clock. Okay. Set, and then you can set clock uncertainty. For clock, you can give set clock transition. So when you say create clock, what all aspects you have to specify? Create clock. Hyphen, you will have to give a clock name.
Set hyphen
You have to
period.
specify the port name on which you want to define the clock, port or pin name. And either you'll have to define a waveform or period, right? The waveform you can specify all the duty cycles 0, 50. So create clock, I mean for clocks, for your level, I think this is, if you answer this many, that's good. What is the difference between generated clock and create clock?
Create clock is the main clock. Generated clock, which is derived from the main clock.
Okay. So automatically generated clock will also have another main source of another clock, right? Source clock minus hyphen master clock. Okay. Where you can again have option like hyphen divide by 2, or you can have edge, things like that you can actually use how you want to specify. Okay. So that's about category of clocks. Now let's talk about category where you are actually defining, constraining the inputs and outputs. What are the constraints? For IOs, what all constraints are there? Set input delay.
Set output.
Set output delay.
Set output delay.
Set output delay.
Set load.
Set load.
D rate.
Set driving cells.
Set driving cell. Set input transition. Okay.
Output capacitance.
And again, set input delay with reference to a clock you'll have to give. Okay. And there could be another one called set max delay between input to output. There's a direct path between input to output, set max delay. That's again an exception, which will try to limit the total delay between input pin to output pin. You understood? Also for the inputs, you can give set max fan out for those things. Okay. And you can give other constraints like, so that it doesn't duplicate that net. Right? You can define the constraint such that the ports does not get, uh, does not get cloned. You can do that also. Okay. But SDC, I mean, I will not give you advanced ones. So, but these are constraints that you can specify. Hello. Yeah. Yeah. Okay. No, thanks. Not right. Okay. Okay. So that's about input output constraining. And what about physical design constraints? So like, you can have set max capacitance, set max fan out. These are all design constraints, set max transition, right? And sorry, for clocks, there are few more. Set source latency. Okay, you can define source latency. You can define balance points. Okay, so those are also possible constraints that you can give for specific to clock ports. So from a physical design point of view, as I told you, you can give like constraints like this. Max tran, max cap, max fan out, and also what kind of cells to use, set don't touch, right? Don't use. All these are design level constraints that you can specify. Then exceptions. That's another category. In that exceptions, again, you can look at multi-cycle path, false path, okay, asynchronous definition, okay. And also you can look at specific to clock exceptions like exclude, okay, stop, float. All these are clock exceptions for the specific to clock tree. You can provide those things. So what is derate and different types of derate used? What is derate?
Derate means difference between launch path and capture path.
No.
Adding the delay values to
For the setup, we can add early derate to capture path and late derate to launch path.
What is the purpose of derate? Why should you derate?
for more pessimism.
Huh?
For more pessimism, like in
Due to PVT variations.
So
yeah, to
because of
extend-
variation in thin, see there is on chip and across die variation, and so mostly when we are talking about across die or across multiple wafers, you have actually them characterized. But within the chip, you need derates because you have to look at IR drop variations within that, chemical mechanical polishing, and various reasons why there will be different cells will have slightly varying differences. Okay. And which you will actually model it using derate. Okay. So those variations you will be able to model it using the derate. What are the types of derate? You can actually derate a cell. You can derate a wire. Right? Net you can do net derate, cell derate. Right? What are the types of derates? How will you choose? There is OCV, AOCV, POCV. These are all types of derates. Okay. So statistical. So SSTA statistical modeling, and you have actually NLDM types. But in this particular case, where we are actually talking, what is the OCV on-chip variation? What's the difference between OCV and AOCV?
in OCV, we are each and every cell have same derate value.
Whatever derate we apply, pessimism, it is applied for every cell.
Yeah,
What about AOCV?
based on the logic depth and
Logic depth and
distance between cells
Distance.
to
yeah,
Yeah.
and where it is positioned. So there's a location based and logic depth based. So if there are more logic in a net, okay. So what happens is because all the cells in the net cannot have same variation because so if as the depth increases, the variation should decrease in that particular case. Okay, so that's the statistical model. So and similarly, if two cells are located on the far away, whether they are close, then their air drop won't be the same, right? If two cells could be different, if the two cells are sitting very close by next to each other, there would the IR drop vary so much that this will have a different derate to the cell which is sitting next to it? Very unlikely. Because of the very nature that IR drop and chemical mechanical polishing can vary with distance, but very close, the variation should be minimal. That's the logic. So that's where advanced OCV came in to identify if these are sitting close by, and that's how you have this how you are actually nullifying the clock derates that you are applying by actually doing what would you do? For common path CRPR, what is common path pessimism removal?
if in launch path and capture path same cell is there, then it will get
Because
two
it's of the
different
same path. The
Yeah.
derate applied to the launch and capture should not be too different because
Yes,
it's the
sir.
same cell. At that point, the variation should be exactly the same. Okay.
Yes, sir. So
Due
we
to
need to remove
CMP
that.
or IR drop, it should though specifically speaking, right? In reality, for the contribution of IR drop when it is actually during the launch versus capture, when you're doing setup analysis, right? During capture, there could be more current drawn. So theoretically, there is possible that the IR drop at the launch and capture on the same cell may not be the same. Okay, but more or less the difference will be very minimal to that particular path, so that you know you will not try to over add more pessimism by creating a completely different D rate. Okay, even though theoretically there could be a small variation factor due to your IR drop difference during the launch cycle versus the capture cycle. So you are going to remove all the cells in the common path. Whatever D rates are applied, you are going to nullify them. Okay, so that's what is actually removing the pessimism in the common path, which either people call CPPR, common path pessimism removal, or CRPR, right?
Okay, sir.
Now what about POCV? POCV is parameterized OCV, where basically it's a sigma derived, where it is looking at whatever is the transition on that particular cell based on which the variation will happen. Okay, the way it will behave is it's also has how the net is actually transitioning, and this again is like and most of the designs now use POCV. You need a POCV tables, and so that whatever if this cell is varying similarly, the variation will pass on to the next quasi interpretation of that. So parameterized OCV is like the characterization of that cell for a particular tran, and how airdrop, how that is going to vary to the output and what is going to be its impact. So all these were added because OCV is the most aggressive one, right? Because by default it applies flatly everywhere, right? You are adding 10%, every cell will become 10% variation, right? Which is actually you are over constraining the design. And that's where AOCV came in to improve that they realistically for addressing very few corner cases, we are attacking, the overall quality of the design. So AOCV came in and POCV became an even more improved version where it really looked at, okay, statistically speaking, for this kind of transition, this is the behavior of the cell. And then it started to parameterize and look at what its variation would be. And, in accordance, it will do that computation. Okay. Okay, what is D rate for setup and hold? Okay, see, D rate are applied like this, right? One is the launch clock D rate. Then there is a data path D rate and a capture path D rate. Okay, so by default, your prime time, how does it analyze for setup? For setup, what it will do is it will assume first it will pick in the setup case, because it has to find the latest path for the launch. First, it will track a net which has the worst launch path. Okay, that will be your launch during setup analysis, and during capture, it will try to find the fastest path for the capture so that the clock cycle will narrow down. Right, that's how your setup analysis is done. And on top of that, you are applying derate means. What it will do is it will look at so with derate, sometimes it's quite possible that your worst path of arrival for setup may not be your worst delay when derate is applied. Okay, because its impact will be slightly different. So the derate launch clock derate data path derate. And again, in the data path, the cell derate, net derate, right? And again, if you look at TSMC documentation, there are, based on your IR drop, it will give a certain derate, and based on your temperature variation, okay, your junction temperature, again, there's a derate. Because as your junction temperature increases, the variation will increase. Okay, so there is a temperature dependent variation, and there is a IR drop dependent variation, which you'll have to use when you are using your POC and for your various factors. So junction temperature and this one you will have to apply. For setup, when you're applying launch clock, you'll apply, like, because the cell delay should be more, the derate will be 1 plus something. So it will be more than one factor. If the cell delay is 20 picosecond without derate, it may become 20 plus 5%, 25%. It will be like 1.25 picosecond it may become. So 1.03, that's how the derate for the launch should be. At the worst case, it should be 1. And for the data, again, because the data should get delayed data path, again, you can have derates which are actually more than 1. The derate which gets applied. For the capture, the derate will be less than 1. It should be 0.9 because the cell delays you are trying to reduce. In the hold case, it is different. Hold case, your capture will become larger path because you want to actually create a bigger period to try and see whether your skew variation, and your launch should be early. That means your launch path, the delay of the cells will be less than 1. On the capture part, the delay of the cells will be more than 1. And data path should be less than 1, or at the best case, it should be 1. Okay, like this. So this should be your way you will analyze the setup and hold with the derate. Are you getting the point? You go through this. If you have recorded this, go through each word, understand, and build your thing like that. Did you work on caliber physical verification too? Again, there's a question. You can say, unless you are a PV, you can say no. What is the block size in your block? Standard question. What foundry did you work? Which technology you worked? What guidelines you used to place macros? Okay. So again, this in floor plan, we have already discussed this question. How will you apply derate for setup and hold for below? Okay. So you look at, there is a unique path for the, whatever this particular derate, right? In the common path, these 3 cells, okay, you will apply the worst derate, but then that will be nullified by the CRPR. And this will be like, for the setup, this will be late derate. This will be early derate. That means you are trying to, the derate will be less than 1. And similarly, data path also will have a worse derate for setup analysis. For the hold, this will be late derate. This will become early derate. Okay. And the data path also will have that early derate. So that's how you will apply your derate. Is it clear? I think the other questions were already answered. Input for PD in details, etc. Okay. Any questions, you can ping me on the channel. Okay. Any questions? Yes. No. Don't know.
We ping in chat, sir, for questions.
Yeah. Fine. Thank you.